In this video, I'll be going over a calculation related to the learning outcome. Describe waves in terms of their wavelength, amplitude, frequency, speed, and intensity. This question comes from ACE Physics Syllabus Code 9702, Paper 12 from May-June 2014. The question reads, what to two significant figures are the period, the frequency, and the amplitude of the wave represented by the graph? Here we can see we're given a plot of the displacement measured in millimeters against the time measured in milliseconds. One of the first things that I would do is, kind of take a look at the answer choices and see what we've got here. It looks like the amplitude is either 0.0067 meters or 0.013 meters because those options are repeated there. So the amplitude, determining the amplitude by itself won't get us to the answer, but it does seem that each value of frequency is unique and each value of period is unique. If you just look at the graph from here, because the wave sort of starts at 0, 0, rises up and then repeats. If this is 2 seconds and that's 4 seconds, 3 seconds is there, that just looks like it's crossing right at 3.5 milliseconds. I can just kind of use my judgment and say, well, that's got to be like a period of 3.5 milliseconds. That's 0.0035 seconds. And so choice C seems like the best answer. When you can make short work of a question in paper 1, you want to, especially if you're fairly certain. The other choice that's kind of close might be this one, and if you can use your judgment, 0.0031 seconds, if here is 3, it would be much closer to sort of this intersection here. We can see that the wave is repeating, closer to 3.5 milliseconds. I'll show you sort of a more formal way to go about the calculation to sort of further prove to yourself that indeed C is the best answer here. If we look at the wave starting here and then repeating, not exactly intersecting 3.5 milliseconds, but kind of we can use our judgment to see that as we talked about. But if we continue to follow the wave, well, there's 2 waves, and then by the time we got to the 3rd wave, now we can see very neatly that the wave is intersecting right at 10.4 milliseconds. You have to be able to read the scaling of the graph to know how much does each square represent. And so if this is 10 milliseconds and this is 12 milliseconds here, then 11 milliseconds would be right at this division. And so each square on this plot then must represent 0.2 milliseconds. In other words, this would get us from 10, 10.2, 10.4 is where it intersects, 10.6, 10.8, and then 11. So every square is 0.2 milliseconds. So I've got 1, 2, 3 waves per 10.4 milliseconds. 3 waves per 10.4. And remember, milli is the same thing as 10 to the negative 3, 1,000. 3 waves per 10.4 milliseconds. Waves per second is the definition of frequency. How frequently are these waves occurring? How many waves per unit time? And so my calculation, don't forget to use grouping symbols when you divide by a quantity in scientific notation. I've got 3 waves per 10.4 milliseconds. Milli being 10 to the negative 3. And that gives me 288.5, which is very close to 290. To get the period, remember, the frequency and the period are inversely related, so I could just hit the x to the minus 1 key, or the 1 over x key in some calculators. And there I can see the 0.0035 seconds of period. So it would round up to 5. Now, let's discuss amplitude for just a moment here. 0.0067 meters is the correct amplitude because the graph rises from equilibrium up to that many meters of displacement. You could kind of see that it's scaled in millimeters, but if we were to convert to meters, we could read that this would be 0.0067 meters from here to here. Students that incorrectly think that the amplitude is the entire height of the wave from crest to trough, which it is not, right? It's half of that height, as we've looked at in previous examples. But these answers here are designed to capture those students' misunderstanding. So if you were to read off the entire height of the wave, you would get this value. Having that value gives you the correct answer for amplitude, 0.0067 meters. And you can kind of see on the graph here, if we go up 1, 2, 3, 4, 5, 6, almost to 7 millimeters, well, that's 0.0067 meters. And so choice C is the correct answer.